My name is Nived Krishnan and I am here to teach you about robotics. Now coming to introduction about robotics. What is robotics? That's the first question we need to answer. Robotics can be defined as a science of designing and building robots, and that robot should be suitable for our real life applications such as in manufacturing industries or any other activities. That is known as robotics. Robotics is defined as it is a science of designing and building robots, and those robots that we build are suitable for other many applications, real life applications. And we can say that this robotics is a branch, it is a combination of mechanical engineering, electrical engineering, electronics and communication engineering, and computer science engineering. Now coming, what is a robot? Many of you think that a robot is a machine that look like human, but this is not always the same. There are many different type of robots already other than a humanoid robot. Okay, but for example, an industrial robot. Example, take a case of a manipulator. Manipulator is completely different from a humanoid robot. Okay, then what is why we develop robots? Robots can we can replace humans for and they can do hard works. That means which are difficult for humans, and the hazardous tasks which humans are unable to do. Such tasks can be done by the robots. They can also take decisions and can do work continuously without tiredness. Okay, then these are the types of robots. Here you can see this is a robotic manipulator, this is a humanoid robot, and this is a robot dog. Okay, then coming to robotic manipulator. As I showed, this is a robotic manipulator. Robotic manipulators are used in manufacturing industries. These robotic manipulators, it is functionally similar to the of our human upper limb. That is all the function that we can do with our hand can be done with the help of a robotic manipulator. Now coming to what is open kinematic chain and closed kinematic chain. I'll show a picture. This is known as open kinematic chain. Here all these individual things are known as links, and the two links are connected by a joint. And if it is open at the other end, it is known as open kinematic chain. And if it is closed like this, and it is closed kinematic chain. Now coming to definition of robotics. Robotic Industries Association is an association. It gives a definition of robot as a robot is a programmable multifunctional manipulator. It is designed to move materials, parts, tools, or specialized devices through various program motions for performance of a variety of tasks. This is the definition given by RIA. Okay, then coming to robot anatomy. What are the parts involved in a robot? The first one is a manipulator. In manipulator includes, as I said, links, joints, and many other structural elements are included in the main body in the manipulator. And another part of the robot is end effector. End effector is a part that is connected to the manipulator. It may be, it may change, this end effector may change according to our applications. For example, in terms of painting robot, it will be a paintbrush, or in case of a drilling operation, it will be a drilling bit will be placed here as end effector. According to applications, this end effector varies. Okay, the example it could be grippers, vacuum cups, drills, spray guns, etc. And they are designed to interact with the environment. Now coming to actuators. What are actuators? Simply, actuators can be known as muscles of a robot. It is a muscles that are used for movement. Examples of actuators are servo motor, stepper motor, hydraulic and pneumatic cylinders, etc. And this help for movement. Okay, then what is a sensor? A sensor is a device which collects information from the environment and give it to the robot. What is what is the use of a sensor? By using the data from the sensor, a robot can communicate with the outside world. Examples of sensors are encoders, camera, touch sensors, force, torque sensors, IR sensors, light sensors, etc. Okay, then controllers. These controllers are, we can say, a computer present in the robot. These are used to control the motions of the our robot. And what is a processor? Processor is a similar to a computer. It calculates robot joints, how fast this robot joints has to move, and how fast this links has to travel, and what is its what should be its motion, what should be its path. These are calculated by the processor. Desired locations and speeds are calculated by the processor. Then coming to joints, there are two type of joints you need to learn. One is revolute. Revolute joints have, it is like this. It will rotate about this. You can see here. Okay. Then another is prismatic. Prismatic joints are like this, where it moves only to and fro motion. Okay. These are two type of robots. Then coming to degree of freedom. A degree of freedom is defined as number of independent movements that is required so that an object can move in a 3D space. Okay, that is known as a degree of freedom. 6 degree of freedom is the minimum number of degree of freedom required to specify the position orientation of our robot. If the degree of freedom is greater than 6 degree of freedom, it is known as dexterity, or condition known as dexterity. Okay, then coming to work envelope. Okay, what is work envelope? Work envelope can be defined as locus of 3D space where end effector can reach. Here, okay, I will show you a picture. Look here. This is we are telling about classification. First type of robot is Cartesian robot. In Cartesian robot, we can here see that here we have 3 prismatic joint. First prismatic joint, it moves to and fro like this. Second prismatic joint move like this. Third prismatic joint move like this. Okay, this is known as a Cartesian robot. Next case is a cylindrical robot. Cylindrical robot, there are 2 prismatic joint and 1 revolute joint. Here we can see that this is a revolute joint, and this revolute joint rotates about its axis. There is a prismatic joint here. Here is another prismatic joint. Okay, next this is a cylindrical joint as I shown last slide. Okay, next coming to spherical robot. Spherical robot, I will show you figure. Yes, this is a spherical robot. There are 2 revolute joints and 1 prismatic joint. This will rotate about this axis, and second one will rotate about this axis, and this third one is a prismatic joint. Okay, then this is known as the workspace created by them. That means this end effector can reach all these points. It is a 3D space, which are the points that can be reached by the end effector. That is known as a workspace. Okay, then there is a scalar robot. It's another type of robot. I'll show you a big figure of scalar robot. Scalar robot, all the joints are 2 joints are revolute and 1 is prismatic, as shown in this figure. Okay, this is a workspace of a scalar robot. Okay, then another one is articulated robot. In articulated robot, all the 3 joints are revolute. It can rotate about these 3 axes. This is known as articulated robot. Then this is a work envelope of articulated robot. It is like a sphere. Okay, then coming to Puma robot. As I told, Puma robot is known as programmable universal machine assembly. This has 6 degree of freedom industrial robot. And this is about my presentation. I hope you understand this. Thank you.